Okay, so number 7 is saying find a cubic polynomial with these following x-intercepts which passes through this point. Okay, so if they're the x-intercepts, just visually real quick so we can see what we're doing. We have one at x is equal to 3, one at x is equal to a negative 3, and one at x is equal to 2. So those are x-intercepts. And it wants to know a cubic polynomial. That means it's going to be raised to that third power, okay, because of cubic. If it said quartic, it would be to the fourth power. If it said the quadratic, it would be to the second power, okay? Otherwise, it'll tell you the fifth polynomial or fifth degree or sixth degree and so on and so forth. And it passes through this point. So this is going to be a point on the actual function, okay? So let's create this point just real quick. It'll be at 0. You put negative 12 way down here. And then let's go ahead and make this go further down, okay? So what our graph is doing is, it didn't say whether the leading coefficient was positive or negative. That is what we're actually going to figure out. So our equation is going to look for that a, and then I'll draw it there at the end to make everything make sense. Okay? So here we go. Our initial setup is going to be y is equal to a, and again this a, we're going to find out whether that's a positive or negative, meaning the leading coefficient will go up or down depending if it's positive or negative here at the end. But then we're going to account for our x-intercepts, these three real x-intercepts. So x minus 3 for the first one, x plus 3 for the second one, again opposite signs, and x minus 2 for the last one. And then what we're going to do is we're going to use this point here to find our a value here at the end. Okay, so let me highlight the x values in orange, okay? So all of these x values are going to be substituted with 0. And let's use blue. This negative 12 is going to be a y value, so that our only unknown becomes a. So we have negative 12, we have a, then we have 0 minus 3, 0 plus 3, 0 minus 2. Again, we're plugging in these values that we were given right here, okay, for x's, and then plugging in this negative 12 for y. And then we'll have a negative 3 times a positive 3 times a negative 2 times a is equal to negative 12. So negative times a negative will give me a positive. So I have 9 times 2 is 18, which is a positive 18a is equal to negative 12. And if I divide both sides by 18, that cancels to 1a. And then I have this as negative 12 over 18, which if I were to reduce it, I could get negative 6 over 9, and then further reduce it. Let's divide it again by 2. So we get negative 3, not by 2, but by 3. So we get negative 2 and 3. Okay, so I divided by 3 from there to there on both of them to reduce it. And I divided by 2 here. So yeah, some of you probably saw it. You could just divide by 6 at the very beginning, and you'd still get this negative 2/3. Okay, so this is our a value. This is what we saw for at the very beginning. So all it does is it now changes our polynomial to where this will be a negative 2/3. Okay, so if I were to rewrite this, this is where I would start. And then you can start distributing everything to see what would it look like if it was expanded and it was simplified with no parentheses. Well, let's review something real quick. The fact that I have a negative leading coefficient now will say that ultimately the graph is going to dip down as I go to the right. As I go to infinity on x, it will go down to negative infinity for the y. Okay, so let's go ahead and expand this. If I FOIL these two out right here, this is a difference of squares because it's x minus 3, x plus 3. And what I could do is I could FOIL this out and get x squared. Then you have a positive 3x. Then the inside terms you have a negative 3x. And the last terms you get a negative 9. Now this will cancel to 0 because you're adding a positive 3 with a negative 3. So you get x squared minus 9. Just for those first two pieces right here. Now some of us can see that and already notice, like we said in class, a difference of squares. So if you want to go straight to it and not write all this work and say, you know this x and x will multiply to x squared. You know that this difference of squares of this 3 and this 3 would go to 9, and that a negative times a positive would give me a negative. You can go straight to that. I'm totally okay with that. Just keep showing the work that you have. So I'm going to take this, and I would have y is equal to negative 2/3. I'd have this x squared minus 9 that I'm going to finally distribute with this negative x, or sorry, with this x minus 2. Now, I'm going to go ahead and distribute now these two binomials, and then I'll distribute the negative 2/3 at the very end. Okay, so let's distribute these binomials. We have x cubed, then we have minus 2x squared, negative 9 times x is a minus 9x, and finally negative 9 times a negative 2 is a positive 18. And then last but not least, I would distribute this negative 2/3 across all of these to get a final answer of y is equal to negative 2/3 x to the third plus 4/3 x squared plus 6x minus 12. Okay? And from here, verification-wise, you can see that the leading degree is going to be 3. Means it's going to be cubic. Okay? So let's graph these the way our questions 1 through 4 in the test review, the way we approach those. We have a negative coefficient, meaning it will go down as I go to the right. Okay. This number is 3, meaning it may have 3 x-intercepts, which in this case it actually does because they gave it to us. Furthermore, because this 3 is an odd number, we know it's not going to have an even symmetry about it. It's going to have this odd symmetry about it. And finally, what is this 3 if I did change the direction? Well, it's always 1 less than the degree, so you could have up to 2 changes of direction. So let's go through. Let's go through 3, change direction once, go through 2. We're going to have to go to this 0, negative 12, and then there's the other x-intercept. We have 2 changes of direction, and I'll highlight them as I go. We have 2 changes of direction. We have 3 x-intercepts. It is a negative coefficient. It is an odd leading degree, and sure enough, we showed that it went through 0, negative 12 as far as that y-intercept is concerned. I only did the graph to further extend and give you a little bit more practice as far as where are all these pieces fitting on a graph, but it's not required for you to draw that obviously on this problem. You were just wanting to find that x-intercept. Okay? And then here, in the context of this problem, you are also wanting to simplify here at the very end by actually distributing all of this answer, not just leaving it in factored form, but actually distributing to our most simplified form, which is over here at the top right.